All right, this is a video on how I wind the Bifilar mag coils. I got a spindle in my hand right here, and I drill 4 holes, and you might be able to see them. There's 2 down at the bottom near the inner diameter. This is a 2 1/4 inch diameter spindle, the outside diameter. The hole in the center is 1 inch. And the spindle is 1 1/4 inches from point to point, we'll call it wide. So I next take one of these inserts that I've made, and it reduces the 1 inch diameter down to a 3/8, so it will sit on top of this bolt, or it'll slip on this bolt. All right, this spindle was just for explanation. I've already slipped a couple of wires coming off of, and you can't see it, it's off the edge, but there's 2 spools. I'll back off maybe at the end of the video and show you that. I'm going to slip these. In fact, I have pictures showing the spools on a pole that I pull the wire from. I put the insert in, and these are nailer plates. I'm going to guesstimate they look like they're about probably around 6x4s, nailer plates. And I drilled a hole in. These are basically the supports for my little homemade wire winding machine. So I'm going to slip this spindle onto the 3/8 bolt. I'm going to lock that spindle down, so when the crank turns, the spindle will turn in relationship to the crank. Put a bolt on there, that's how you have to lock it. So the setup detail is probably not that important, but it helps give us a visual and just better explanation for how this whole thing is put together. There's a washer on the other side where my finger is, and I'm just twisting it because it's got a flat that's used to miss scraping the wires. Okay, hand tighten. Okay, it is hand tightened, and you just need a little pressure. You don't need much, and that's pretty much it. All right, so we'll now put this bolt into the nailer plate. Put a washer, a sleeve, I made a mistake. I got to put a bolt first. A bolt. I hate when I do those silly things. I don't do it when I'm not making videos. I only do it when I'm showing people, huh? Okay, so the washer back on, the sleeve back on, and now I put everything through and the nailer plate, and I put a washer on, a screw on, and everything is got to be tightened up. Okay, we have the spindle ready to be wrapped. I take these loop wires and just bend them so they won't be in my way. Now you see a motor here and you say, well, he's going to turn on the motor and just wrap that away. I can't use the motor. It is way too fast, no matter how slow I get it, to do a reasonably neat job with getting these wires on. So I put this crank on here and I hand crank it, but I do use the motor, and you'll get to see where I use it. I use it to actually help dry the polyurethane that I put over the wires because it spins after it's all done. All right, so here we go. We're going to put one layer on, and then I'll take and pause the video, finish it up, and then I'll pick up again at the very end. So here goes the first layer. You can see I'm turning it. and I'm holding the wires with my hands, and I'm putting them on, and I push them all together so they look nice and neat, really clean windings. The first layers are always really good looking. I mean, they're really tightly wound. There's 2 wires side by side, filling up the spindle real nice. And I go back and forth with 8 wraps. Okay, so I'm at one end. So the next thing I do is I varnish, or in this case polyurethane, not varnish, excuse me. I put a little polyurethane on, and this holds the wires in place. Takes about a day for it to really dry nicely. It dries in a cursory way in about 20 minutes, but it takes a little longer for the polyurethane that gets covered over with other wire wraps to dry. So you can see I have one nice, really clean wind. Really looks good. And now I'm going to go back. And the first couple of winds back and forth, pushing the wire, whoops, really go on really nice most of the time. Push all the wires together. It's what happens though eventually when you switch direction, the wires want to run in the grooves of the previous loop, previous level of wires, and it actually gets pretty hard to get this thing to stay neat by the time you go back and forth. Perfectly neat is what I meant to say. By the time you go back and forth 6 times. All right. So now I've got back and forth 1 time. I'm going to do that 6 more times. But of course, before I go any further, I put some more polyurethane on. So every level gets polyurethane. And if you sort of timed how long it took me to go back and forth, it only takes a couple of minutes to do 1 level. But I'm going to do 6 levels back and forth. We'll call a level. I'm going to pause the video, do the job, and I'll pick it up when I get to the last level. All right, we're back. We wound the coil, and now we have to get the wires through the 2 upper holes on the outside edge of the coil. And we have to do that without all springing back on you. One of the advantages to leaving the motor on, it creates drag, so the wire doesn't want to unwrap. The wheel doesn't want to turn backwards on you, and then you get a big ball of unwrapped wire, which is a real pain, and it has happened to me. So the next thing I do is, when I get to the stage where I'm just going to cut and get ready to slip the wires through the holes, I tape the outer edge. I'm taping. You might not be able to see it from the vantage point that the camera's looking at. But I take black tape right here, and I'm taping it so I can cut the wire and it won't unspring on me. I think that might make sense. The wire wants to unspring. It's wound like a spring, and I want to prevent that from happening because it's a real problem when it does. Okay, I hope I communicated on that. All right, so I'm going to cut 1 wire at a time, and I'm going to cut the wire that is going to go to the hole that's closest to me, and you'll see how that whole process works, and that's this wire right here. So what I do is I cut it reasonably close. I only need about an inch beyond the spool edge to work with for when I actually put the other wires on. Okay, so it's been cut. And what I do, I'm reaching back right now. You can't really get a good handle on this, but I'm reaching back and I'm putting the wire from the spool back into the spool so that won't do a big spring unwrap on me also. So here is the wire right here. And it's got to go through a little tiny hole at the edge of the spindle. And I use a X-Acto knife bend it over, and I poke the wire into the hole, and hopefully this will go easily. Sometimes it's really hard to do. And this is a case where I got a burr on the wire, and it's really important to have some good dikes, because good dikes will have a tendency when you cut the wire not to leave a burr on them, so they will go through the hole. And you can see them fighting. You can see I'm fighting. And the tape is coming undone. So what I'm going to do is I'm going to stop the video. Alright, I had stopped the video, went and got a better pair of dikes because I needed to get the burr off the edge of the wire. The dikes left a burr on it. I couldn't poke it through the hole. So there's a good lesson. New dikes, old dikes, and they're going in the trash. They just went into the trash. Alright, so I pull the wire through. It's a little hard, but you can do it. And I just keep putting tension on it, pulling it through the hole, and get it as tight as I can. And take out the slack from any unfurling or unwinding. Okay, I got one wire in and one wire done. Now I have to do it to the other wire. So I take my new dikes and I cut the wire again. You just leave about an inch to a couple inches at the most. Nice clean cut. And I'm reaching over. You can't see it again, but I'm hooking the wire back onto the source spindle it came from, so it won't just all unfurl at the spindle level. Okay. Here's the second wire. I want to get through the second hole, and it should not be too difficult because I got a nice clean cut when I use the new dikes. And let's see if we got thing. Oh man, that just went right through. How nice that was. Excuse me. How nice that was. And I'm going to pull this wire through, and there we go. Got it in there. Nice, nice. Nice, nice. I really like the way that came out. All right, I got to sit down and relax here. I was standing on my tippy toes trying to get this done. Okay. You can zoom in, and here's how I had the tape. You can see how I had the tape there. I'm going to remove the tape because what I'm going to do now is I'm going to saturate it in polyurethane. And you'll notice the wires, although they are spun, they're sitting side by side, there's gaps in there and everything. And that's just because the wires want to ride in the grooves of previous winds underneath. By the time you get to the top, it's pretty hard to keep them side by side, tight and perfect all the way around. Okay. And now here is the fun and easy part. I'm going to dunk this thing in polyurethane. So there was a comment about how unsafe this coil was because the wires were exposed. First of all, the wires are heavily enameled. And then I heavily polyurethane them. You can probably see how thick I'm putting it on. And they do two things. They fill in the gaps a little bit where the wires aren't side by side. They freeze the wire in place. When that polyurethane dries, the wire is not going anywhere. And I really saturate it. And I put a lot on there because the polyurethane is now finding its way down through gravity. As I turn it anyway, it's finding its way down into all the loose windings below the outer layer. So when this dries, this coil does not vibrate. It's sort of like rock solid. And the polyurethane can take the heat, more heat than the plastic. So you can worry about the plastic melting first if you decide to run this coil with a PEMF and run it for in excess of 30 minutes, and you go for a couple hours, and then you come back and you see your spool has been sort of deformed. You were warned. But running it as a scalar wave device or a magnetic wave delivery device from the Spooky, you can run it all day long, and nothing will ever happen. It doesn't get hot. It only gets hot with the PEMF energy, pulse electromagnetic field energy, provided by the PEMF unit that this coil was actually designed to work with. It was to give this coil a lot of multi-capability. It's a multi-purpose coil. Okay, so now you can see that you might be able to see. It looks like a lot of polyurethane. I'm looking at the video too. And what I do next is I just sit here for a little while and let that polyurethane sink into the center of the coil. And it will sink. And I cover the top. I'm all finished with using the polyurethane. And I cover the top. There we go. And you can see in places where from the top it sinks down in and it wants to drip on the bottom. I have a paper towel here to take the dripping, and it can drip all it wants. That's fine with me. It's not going to hurt anything. And now I go and I do other things. I wash the brush out. Invariably, I might even take a 5-minute break, and I come back and I turn this a little bit more, and then I spin it. I spin it when the polyurethane has dried enough so it won't spin off while the unit is spinning. And I'll show you that too. I'll come back and turn the video on. I'll link all these videos together. All right, I'm back. And the only reason why I'm back is to just show you the spin. There's still polyurethane on the outer edge of the coil, but now it's mostly sunk inside. Very thin layer on the outside. And I just run that for 5-10 minutes, and the polyurethane dries enough so I don't have to run it anymore. And that's pretty much it. I can back the camera off just so you can see the spools that I was pulling wire off of. If I can do this neatly, there you go. So there's where I was pulling the wire off of 2 spools. And there's the unit spinning. So there's not much more to say at this point in time. I'll let this run for 10 minutes. I'll do something else. Maybe run for 15 if I forget to come back. And the coil will be all wound. It still has to be connected up with wires and so forth, and I have to make the adapters. It takes about a half an hour to do what I did here, to wind the coil. So a half an hour of labor just to get the coil wound. All right, that's the end of the video. I hope it worked for you, and thank you for watching.